Okay, so if you remember from our last video, we substituted the time right here into the I component of our equation, where this was the initial velocity and this was the angle. And we got this distance that the rocket traveled, 62.1723 feet. So now the part of the project was to rescale this to more, I guess, bigger scale. So we said that 62.1723 feet is now equal to 62.1723 miles. The first thing I did was convert this miles back into feet. So I did this just by saying that there's 5,280 feet in 1 mile. And when you multiply this, you'll get 32,269.74 feet. Okay, so now we have our new distance traveled. We need to figure out what our new initial velocity is and the new time that it takes to get this 62.1723 miles. So the first thing that I did was I looked at the I component of the vector equation again, and that says that V naught times t times the cosine of 46 is equal to, that would be the distance in the x direction. Well, we already know what the distance is. It's right here. So we set it equal to that. And now we can solve for either t or v naught. I'll go ahead and solve for v naught. So we can say that v naught is equal to 32,869.74 divided by cosine of 46 times t. Alright, so now that we have what v naught is equal to, we can substitute it back into the j component to find out the time. So remember that the j component would be v naught t times sine of theta minus 16.1 t squared. So we know what v naught is. So if we go ahead and do that, we can say that v naught, which is here, is 32,869.74 divided by cosine 46 times t times t times sine of the angle, which was 46, minus 16.1 t squared. So we know that these are going to cancel out, and I'm not going to do it here, but if you were to work it out by hand, you could use the quadratic formula, and you would find that t is equal to 0 and 145.3061, and those are seconds. So now that we know the time, we can say 145.3061 seconds. We can put that in right here and solve for V naught. So V naught equals 28269.74 times cosine divided by cosine of 46 times 145.3061, and that's going to be equal to, after you work that out, 3252.1887, and that's feet per second. So put that here. Okay, so now we know our new initial velocity, the new time that it takes to get from where we launch the rocket to where it lands. So let me go ahead and draw a little picture. So our new picture will look something like this. This is our rocket. Our angle stayed the same. It was 46 degrees. Our new, let me go ahead and convert these for you too. We said that it was 3252.1887 feet per second. If we multiply that by 3600 seconds in 1 hour times 1 mile, that's 5,280 feet. That'll go away, that'll go away, and that'll be equal to 2217.4014 miles per hour. So our initial velocity was 2217.4014 miles per hour. Our time to get to our here, this point where we landed, was 145.3061 seconds times 1 minute 60 seconds. So this will cancel and be equal to 2.4218 minutes. So from launch to land, it took 2.4218 minutes to travel Our distance was 62.1723 miles. And that's it. So after we rescaled everything, we traveled 62.1723 miles and with initial velocity of 2,217.4014 miles per hour at an angle of 46 degrees, and it took us 2.4218 minutes to get there.